Hello guys, and welcome back to Epic Mentorship. Today's video is an on-demand video. I'm going to solve just one example using Epanet. I've done a video on Epanet before, but I was requested to do another one solving a simple example. So in today's video, we will solve this question, which is very simple, so direct. A 50 feet diameter tank is located in a city to supply drinking water for a small community. Okay, the tank is 20 feet high and is located 400 feet above the city. The tank supplies water with a constant flow of 4 cubic feet per second during the day. All the nodes in the network are located at 0 feet elevation. All the pipes have a roughness of 100. Use Hazen-Williams formula during your calculations. Minor losses are neglected. Table 1 shows the length and diameter of each pipe. Calculate the flow and velocity in each pipe and pressure in each node in the network as shown in figure 1. So figure 1 is the network where we are going to consider our water supply problem. So this is the tank and this is its properties, and then these are the other elements. We have the pipes, pipe 1 to pipe 21, and then we have the nodes, and this is the pipe configurations. We have the pipe numbering, we have the pipe length, which is constant at 50, and the pipe diameter is 12. And then down here we have the water demand on each node. Okay, we have on each node 1 to node 17 all the demands are stated clearly. And then we will set in the first case we'll consider the whole network to have a constant supply through a constant demand throughout the 24 hours. And then in the second case we are going to consider the use of multipliers, where we have the demand varying according to the timeline in the network. To start with, you can download the Epanet software. Anyone who has watched the previous video will know how to download the Epanet software. It's an open software, free to use and to share with your friends. You can download it from this website, epa.gov. So it's a water research software. You can just come over here straight directly and click on the download button. You can download either the executable file or you can download the software in a zipped format, and then you can unzip it and install. But I prefer to download the executable file directly. So clicking on this, you can easily download it over here. It's a very simple and weightless file, 3.5 megabyte. So once it finishes, it's a click-through website. You just locate the location of the software, and then you can just double click to start the installation, and then you can install it directly. It's a click-through software, you can just install it. So once you finish the installation, you open Epanet by just typing on Epanet. So this is the Epanet windows that it opens to us. For those who have the basics before, must have understood some of the key things that are in this software. But for the benefit of beginners, you can just give an initial overview of the use of the software. So this software is a water distribution network analysis software that it can monitor the flow of water within a particular community. It can monitor the flow, the velocity, the demand on each and every node or on each and every location in a particular area. So you can design the water distribution network of any community using this small software before you go to the community and run it. You can put in all the elements, all the features that are needed. You can put them before you go to the community. So you have the map area. This is the network map area. Okay, other things that you have are the other key features like the nodes, the tank, the reservoir, the tank, the pipes and the pumps and all that. And then you have a range of other things which we can use as we proceed with this example. So in this example, as we have shown in the network, it's a very simple network. So as usual, the first thing when it comes to pipe network analysis, the first thing you need to do is to start by setting up the project defaults. To set up project defaults, all you need to do is to come to project, and then you go straight to defaults. So these defaults are features that will appear on all the elements that you are going to specify later on in the map. So for this one, you're going to look at the ID levels. The most important part here is to make sure that the incremental level is set to 1. That is the first thing. And then you can go to the properties dialog, and over here you should make sure you state all the node elevations. But in this case, it has been stated clearly in the question that all the nodes are at 0 elevation, so we have them at 0. You have to state the tank diameter, and you have to state the tank height and the pipe length. Other things like pipe diameter, you have to state them here, and then the pipe roughness. In our own example, the tank has been stated to have is 50 feet high and is located at 400 feet above the city. Okay, so we can just specify that it's 50 feet, 20 feet high, and the diameter is 50. All the nodes are on the elevation 0 feet elevation. All the pipes have a roughness of 100. Hazen-Williams should be used. Length is 50, so the pipe length is 50, so we have to specify pipe length as 50. The tank height is 20, the tank diameter is 50, and then the diameter of the pipes is 12. Pipe roughness is 100, it's given. Next is we can come to the hydraulics part, and we should make sure that the cubic feet per second is selected, not gallons per minute. So cubic feet per second, this is the flow unit. And then we should use the Hazen-Williams. It has been stated in the question that we should use Hazen-Williams. And I think at this point, that's all for the defaults. You can click on OK. And then the next thing is we go to preferences, click on the file, preferences, and then we make sure that at the general button, all these are selected except the clear file list, blinking map Hitler, and flyover map, labeling, confirm deletions, and automatic backup file. All these are very important, so make sure they are selected. The formats, I think no need to touch anything here, and then you click on OK. The next thing is to draw the map, the network as it is, as you see it like this. We have it exactly as it is like this. We have the tank, and then we have the pipes located at different points extending from one node to another. So we will draw the pipe just like this, the way we have it like this. So we start with drawing the nodes. We have node 1, node 2, node 3, node 4, node 5, node 6, up to node 17. So we can just click on the node and then add. We just click node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, and then we have node 10, we have node 11, 12, 13, 14, 15, 16, and 17. So we can easily draw our pipes accordingly to these nodes and to connect them. So all you need to do is to come to the pipe over here, click on it, and then we can start drawing the pipe links. So we start according to the pipe that we have in the description. So we have the arrangement: pipe 1, pipe 2, pipe 3, pipe 4, pipe 5, pipe 6. Okay, so we'll draw it according to this. But before we draw the pipes, next is we decide to put in the tank, which we have at the top here. We click on it and we have it at the top left here. So this is our tank. So the next thing is to start drawing the pipes. So we have click on the pipe, we click pipe 1, straight from one element to another. So we click from the tank to the first node, and we have our pipe 1 here. And we can have pipe 2 to click from node 1 to node 2, like that, and pipe 3 click from here to here. Don't worry about the straightening of the pipes, we will straighten them later on, and then you can see them looking professional. And then we have the next one, we just join from here to here, from here to here. Later we will straighten them and we will give the label, the appropriate label that is needed. So from this to this, from this to this, let me do it quite quickly. Okay, so this is our network. It corresponds to exactly what we have on the map, but like I said, don't worry about the straightening. I will show you how to straighten them. So to just straighten this network to look professional, all you need to do is to come over to the select object here. You click on it, and then you can come and start straightening it just by clicking on an object, and then you drag until you see it appear quite straight. So once it appears straight, you can click on another one, and then you drag until it's straight. You can go to the next one, just click, and then you drag until it appears straight. Then you can click on the down one, you can straighten as well. Okay, this is straight, and then you can click on the next one, and then you can drag until it straightens. You can click on the next one as well, and then you drag. Yeah, so I think the network looks a little bit much more professional now, and we can say it is quite fantastic. So the next thing we should be mindful of is the labels of the elements. So we can enable the ID labels on the map just by coming to view, and then you can come to options over here. We can come over all the way to notations, and then we can say display node IDs, display node values, even display link IDs, and then display link values when we have one. So you can, once you specify all this, you can just click on OK, and you can see automatically the IDs are automatically on the elements. So this is tank 1, which is the 18th element that we have put. This is node 1, node 2, node 3, node 4, node 5, node 6, up to node 17, and then we have them equally spaced and arranged as we have in the network. So the next thing is to specify the properties, but we can check to confirm that the labelings are correct as we want them. Like the pipes, we have pipe 1, 2, 3, 4, 5, 6, 7, supposed to be 7, 8. So you can label them as you wish. We can call this pipe 1, or if you want to call it, change the label, you can double click and then you can make it P1, maybe for pipe 1. Once you select, you close, it takes it, pipe 1. Okay, this is pipe 2, so you make it P2. So you can do the same for all the other ones. Okay, so we have the pipes renamed from pipe 1 to pipe 21. So the next thing is to specify the properties. Okay, let's try to rename the tank as well, so it takes its name. This is a tank. Okay, so we take it as a tank. So we have the tank over here. Alternatively, if you want to put in a text, you can come over and click on this, and then you can click anywhere, and then you can put, for example, the tank. Once you click on when you click out, you can move it to any location of your choice. So this is very easy to use. But alternatively, again, you can do the same from the properties dialog to change the name of the element. Okay, so next is we can specify the properties of each element. So we start with the tank. So we double click on the tank to access the properties. Okay, so these are the X and Y coordinates, which is depending on their location on the map. So you cannot touch anything, but if you know a particular coordinate system that you want to put, you can easily put, and then you draw the map just like that. But it's easy to just do it manually to have it well arranged. So the elevation of the tank, we have to specify initial level, maximum level, and then the minimum and maximum level, and the diameter of the tank. So based on the question, we knew that it was given in the question that the tank has an initial level of 10, elevation 400, diameter 50, and height 50. So we just specify this in the dialog. Initial level 10, elevation 400, diameter 50, and then we have the height to be 20. The maximum level is 20. So this is correct, and so this signifies that we are done with the properties of the tank. So you close, and then we can come to the elements. in the elements, all we need to specify actually is the elevation, which we have known to be 0, and then we have the base demand on each node as stated in the question, and then we have the base demand. So the base demand is what we will specify on each of the node. For our own case, we understood that the flow on from the tank is 4 cubic feet per second, and we have the initial demand on the first node as 0.15. So we are going to subtract 0.15 from 4 coming in. Okay, so this is what is coming into the node. Okay, so we subtract this and we have negative 3.85 as our base demand on node 1, negative 3.85. okay, so this is what we need to specify. All other things no need to touch. And then we'll go to node 2 the same way. The base demand is node 2, the base demand is 0.18 cubic feet. Node 3 is 0.18. So node 3 0.13. So we are going to specify the same for all the other nodes. Okay, so I put all the base demand on the nodes, on all the nodes as per in the question that we have. So we just replicated it here and we put in the tank properties, and then the next thing is to put the pipe properties, which we have already specified in the default. So the key thing that we need on each pipe is the pipe length, the pipe diameter, and the roughness, and we have already specified this on the default. So this is going to be the case for all the pipes, except if you have a specific case when you have to specify otherwise. Maybe within the network there is a specific place where the diameter and the length are varied. Okay, but in this case everything is constant as we have. So it's going to be the same for all the pipes. So this is pipe 1 and these are the properties, and this is pipe 5 and these are the same properties. So all the 3 things we need are already stated in the pipes. So the pipe properties are already stated from the default section. So the next thing is, okay, so at this point maybe we can try to save it so that we can have it as a backup. In case of anything, we can always click back and open it from where we saved it. So to save any Epanet project, all you need to do is to come over here to file, and then you can go to save or save as, same way. Okay, so you can go to any location and you just specify the location where you want to save, and then you can put in water supply. So we save. Now it is saved. To try to run the simulation, because we can confirm that all the other properties have been inputted correctly as we want them from the question. Everything is inputted correctly. So to run a very simple simulation, all you need to do is to come over to the run icon here and just click on it. So if it is successful, it will show you. If it is not, it will give you the error message and it will tell you why it's not successful, and then you can follow up and edit accordingly. So let's try to run and see the run was successful. We can just see the run is successful, so we can click on OK. The next thing is to view the results since our run is successful. So to view the results, we can come over to the map icon from the browser here and just click on the map, and then we can show the results on the nodes, on the links, and we can see the time period over here. So let's say on the node we want to display the pressure. So what are the pressure? Okay, so we can see on each node we can see the pressure, and then we can see the legend describing the pressure on the nodes. And next we can say on the links we want to see the velocity, for example, on each. So we can see the velocity on each node, and we can see the legend describing that velocity. So these are the nodes property, the results on each node and on each of the pipe element, and these are the legend describing them. So we can change, okay, on the links maybe we want to see the flow. Okay, we can see the flow as well on the pipes, how it varies accordingly throughout the network, and so much more. So the next is, let's try to look at the results on the tables on a tabulated format, the results in a tabulated format. So all you need to do is to come over to the tables over here and just click on the table, and you select the type, which is a network nodes. So this is on the node, and then we can click on OK, and we see all the results. Okay, this is the demand in cubic feet per second that we have specified, and then this is the head, this is the pressure, and this is the quality. So you can look at the variation accordingly within the as we move from one junction to another up to the tank. So this is just the tabulator result, and you can print this out, or you can select it and highlight and just print it to your report. And the next thing is, we can, maybe let's say we want to see the result on the links. Okay, we click on links, and then we can see the velocity, we can see the unit head loss, we can see the friction factor, we can see the reaction rates, since we don't have all these parameters specified as part of the things we're looking out for. So we can even see the quality if we have specified that we wanted this. Okay, so this is the flow in cubic feet per second accordingly throughout the system. So we can see it across the pipe, just like we have seen it here. This is the graphical form. Okay, so showing the data as it is. After running the first simulation and saving the work, the next thing to note is that we have run this pipe network on a very simple case. We assume that the demand on each and every node is constant throughout the time for the 24-hour period that we have, which is virtually not going to be possible because we need to be realistic with the system. There are lots of variations that happen within the day. Sometimes we may have students on the hostel, for example, if we're designing for a particular school or for a particular community. If we may have more people during a time of the day and less people during a time of the day. Maybe some people have gone to work, some have gone to the farm, so there will be less usage of water in that community. And maybe at a given time when everyone is back, we will notice a very great increase in the level of usage of water throughout that community, or throughout that hostel, or throughout that school, depending on the case that you have. For us to try to vary the demand on each node according to the time frame, we need to introduce the multipliers. That's why we have the multipliers given in the question. In our own case, we have 24 hours variation across the whole hour. What happens at 1, 2, 3 up to 24 hours. So we're going to input in all these multipliers to signify the level of the quantity of the demand on that particular node. Right, so to add a new pattern to this particular network, all you need to do is to make sure that at the data portion of this browser, we select patterns, and then we click on new to add a new pattern into this dialog. So we can name the pattern, we can have it as 1, and then we can give it a description. Maybe we can say variations, and then for this case we have to input the multipliers accordingly, according to what we have. Okay, so we'll input the multiplier accordingly for the whole period of 24 hours that we are going to consider for this case. Okay, so it's just 24 hours, so we'll put in the multipliers accordingly. In the first hour, 1, 2, 2, 5, 8. Okay, so accordingly you put the remaining ones. Okay, so all the multipliers are inputted accordingly as we have in the question, and then we can see it here, and this is the small multiplier curve that we have, and you can see the average value at 9.80. Okay, so once everything is set up and we've inputted everything, all you need to do is to click on save, and then we can give it a name and say save, and then we'll say okay. So now we have inputted the pattern. So the next thing that we can do is to create a time series for our network so that we can run the simulation completely. So to run a time series, all you need to do is to come over to the browser here and come straight to data, and then we can come over to options, then we select times because we are considering time series plotting. So we click on times, and then we click on this edit button, and then we can put the total duration to be 24 hours because we are considering 24 hours for our case. Okay, once we input 24 hours, we close. Then at this point, we can still run another simulation to see whether it's successful or not, but this time it's going to be for 24 hours. Okay, so the run is successful, and let's try to visualize the results again in a much better way graphically. Okay, clearly we can see the pressure variation on node 4, so we can see it graphically as it appears. So this is actually how to plot in the results on nodes. You can do the same on the on pipes if you want. Basically, this is how to solve a very simple simulation using the Epanet software for any given water distribution network within a community or from any kind of catchment that you want to design and develop. If you like this video, kindly hit the like and subscribe button to keep enjoying related videos like this. I will see you in my next video. Bye.